Welcome, viewers, to Bodhi Unified Flow. Here, we simplify complexity and amplify performance. Today, we are diving into an explainer that, honestly, completely redefines what it means to be a modern civil engineer. We're unpacking the topic, the Blueprint Revolution, a 4-year roadmap to civil mastery for BE and BTech civil engineering. And we are zooming in on a very specific efficiency engine, lean and project management. We're going to focus entirely on the management side of engineering today. That means we're stepping away from just the technical execution, and we're learning how to truly master production management. We'll explore how to identify invisible waste on your site, how to optimize a highly volatile supply chain, and how to use powerful systems like the Last Planner system to keep your projects relentlessly on time and on budget. Let's get right into it.
So, here is our roadmap for today. We'll kick things off with the productivity crisis, then move into the lean construction philosophy. After that, we'll break down the 8 wastes, explore the Last Planner system, discuss optimizing the supply chain, and finally wrap up with mastery, summary, and our references.
By the end of our time together, you're going to have a completely new perspective on job site operations. Our goal is to give you highly actionable frameworks. You'll be able to recognize the multi-decade productivity stagnation we're facing and understand exactly how lean construction flips the script. We'll make sure you can identify the 8 on-site wastes, grasp the Last Planner system's 5 conversations, and confidently apply just-in-time logistics. Ultimately, you'll see the exact 4-year educational path you need to transition from a purely technical executor into a management-centric leader.
Let's start with Section 1, the productivity crisis.
We really have to start by exposing a harsh reality. The way we've traditionally built the world is fundamentally flawed. Think about the stark contrast between manufacturing and construction. Since the 1960s, manufacturing has just taken off like a rocket, right? Exponential growth in output and efficiency, fueled by highly integrated, technology-driven systems. But construction? Well, we've suffered a multi-decade stagnation. We've actually seen a relative decline in output per man-hour. It's crazy. Why is this happening? Mostly because traditional project delivery is super fragmented. It's plagued by adversarial relationships between owners, designers, and contractors, which just leads to chronic schedule delays and massive budget overruns. Being a whiz at structural mechanics just isn't enough to fix this anymore. We desperately need a revolution in how we manage production.
That brings us to Section 2, Lean Construction Philosophy.
To solve this massive, systemic crisis, the industry is turning to a paradigm shift borrowed straight from the Toyota production system. Now, lean construction isn't just some corporate buzzword. It's a deeply respect and relationship-oriented production management system. Lean operates on a pull system, entirely replacing those old rigid push schedules that almost never survive first contact with reality. And the absolute bedrock here, respect for people. Lean recognizes that real value is generated by humans working in teams. If you don't empower your workforce, they simply won't share the innovative ideas you need to improve the process. From that foundation, we work to optimize the whole by breaking down silos between trades, systematically eliminate waste, focus heavily on uninterrupted flow, generate pure value for the customer, and constantly iterate through a cycle of continuous improvement.
Moving on to Section 3, eliminating the 8 wastes.
If our ultimate goal is to eliminate inefficiencies, we've got to know what they look like in the wild. In the management side of civil engineering, waste has a very specific definition. It is literally any task, resource, movement, or delay on a construction site that does not add value to the end user. It is pure, unadulterated economic loss. Identifying this waste is step number 1 for any management-centric engineer who wants to optimize flow and drastically shrink project costs.
To help spot these inefficiencies, we use an incredibly powerful framework called the DOWNTIME acronym. Just think about waiting for a second. A whole crew standing around waiting for a structural engineer's approval. It happens every single day, and it's just draining your budget with idle labor costs. Or what about non-utilized talent? That's what happens when you completely ignore a highly experienced foreman sequence suggestion. You lose out on innovation and crush morale. Consider transportation and inventory too, like bringing all your AAC blocks to the site weeks before they're needed, causing massive congestion and theft risks. Every single one of these 8 wastes, defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing is an operational misstep, and it's your job as an engineer to systematically hunt them down and eliminate them.
Let's dive into Section 4, the Last Planner system.
So now that we know how to identify waste, we need a robust mechanism to actually control our production in real time. Traditional scheduling often fails miserably because it's created by project managers sitting in a trailer, completely in a vacuum, far removed from the dirt and reality of the job site. The Last Planner System, or LPS, flips this entirely. It empowers the last planners. These are the foremen and trade leaders who are actually assigning the work to the crews on the ground. By shifting authority to the people closest to the execution, we dramatically increase planning reliability and completely kill off that toxic culture of the blame game.
Okay, so how does this actually play out on the site? It happens through a chronological sequence we call the 5 conversations. First up is master planning. This is where we establish the project's major milestones, essentially defining what should be done. Second is phase planning, where we use pull planning to work backward from a milestone to sequence the handoffs between trades. Third, and this is absolutely critical, is look-ahead planning. This is where we look 4 to 6 weeks out to manage constraints like missing materials or permits and clear them so the work actually can be done. Fourth is weekly work planning, where we make rock-solid commitments on what will be done, scheduling only shielded, constraint-free work. And finally, learning, tracking what you did and analyzing any variances to fuel continuous improvement.
When you shift to this collaborative system and use visual planning boards, the results are just staggering. Implementing the Last Planner system has been empirically shown to boost percent plan complete, which is a key metric of scheduling reliability, from a really chaotic baseline of around 55% all the way up to an impressive 80%. It literally transforms the entire site culture from reactive firefighting to smooth, proactive execution.
Next up, Section 5, Optimizing the Supply Chain.
You see, establishing that beautiful flow on site is practically impossible if your materials aren't arriving correctly. A management-centric engineer has to completely rethink inventory. The old-school way is just in case, ordering massive stockpiles of materials far in advance. But that drives up storage costs, vastly increases the risk of damage, and creates horrible on-site congestion that literally blocks the trades from working. The modern efficiency engine relies on just-in-time, or JIT. Materials are delivered exactly at the moment they are needed for installation. This approach is a total game-changer. It radically improves cash flow because you aren't paying for unused materials, and it keeps the job site clear for fast, uninterrupted production.
But listen, it's a balancing act. You can't just use just-in-time for absolutely everything. A master engineer calculates the specific frequency of procurement based on a material's risk profile. Take reinforcing steel, for example. It's super critical. A stockout stops the whole project dead in its tracks. So, we use a 14 to 21-day bulk procurement to ensure a safe buffer. But look at AAC blocks. They take up a massive amount of space. For those, we use short-cycle replenishment every 3 to 7 days to minimize congestion. And what about delicate, highly expensive materials like curtain wall systems? For those, we strictly use a 1 to 3 day just-in-time delivery to align perfectly with installation and prevent any damage.
To make sure those finely tuned material deliveries flow flawlessly through the site, we rely on TACT planning. TACT is essentially the heartbeat of production. It paces the trades so they move through geographic zones in perfect synchronization, preventing overlap or idle spaces. But here's the catch. TACT planning only works if the physical environment supports it. That's exactly why we implement the 5S methodology. We sort out the junk, set everything in order, shine the site for safety, standardize our processes, and sustain the discipline. Doing this completely eliminates workplace friction.
Finally, we reach Section 6, Mastery, Summary, and References. So, how exactly does a student evolve into a true master builder capable of wielding all these incredible tools? Well, it happens through a structured 4-year educational roadmap. In year 1, alongside your fundamental statics and dynamics, you start building digital literacy with Python and get a solid grip on lean basics. Year 2 transitions heavily into site applications. You master surveying while actively implementing visual management and the 5S system. Year 3 is where production control really takes center stage. You deepen your structural design knowledge while running Last Planner system workshops and modeling supply chains. And finally, Year 4 brings advanced integration. This is where you merge building information modeling, or BIM, with lean principles and master collaborative commercial frameworks like integrated project delivery. This whole journey creates an engineer who isn't just a technical calculator, but a true master of production.
And I want to be really clear here. This isn't just some academic theory. The empirical evidence from the real world is overwhelming.
Just look at major global infrastructure. At Heathrow Terminal 5, establishing logistics centers, shielded deliveries, and kept a massively complex project on track. At Morocco's Mohammed VI Tower, lean tools minimize quality defects despite crazy structural complexity. And on Indonesian toll road megaprojects, actively identifying and eliminating non-value-added activities resulted in a massive 19% reduction in overall project completion time. This management methodology scales to literally the largest projects on Earth.
To summarize everything we've covered today, we've successfully mapped the transformation from a technical executioner to a high-level, management-centric leader. We exposed the multi-decade productivity crisis holding the industry back and outlined lean construction as the ultimate efficiency engine to fight it. We deconstructed exactly what waste looks like using the DOWNTIME acronym and established real production control via the 5 conversations of the last planner system. We showed how to balance supply chain optimization, and finally, we laid out the 4-year roadmap to achieve true industry mastery.
As we wrap up this explainer, I want to leave you with one final, provocative thought. You now know for a fact that the construction industry is bleeding capital every single day through invisible wastes like weighting, motion, and overproduction. But the tools to fix this, they are right in your hands now. So what specific step will you take tomorrow on your job site to become the efficiency engine your project desperately needs?
Here are the specific sources and research papers we synthesized for today's explainer. I highly encourage you to explore these texts further. They provide the granular, real-world data proving that mastering the management side of engineering truly is the blueprint revolution of our modern era. Thank you so much for joining me here at Bodhi Unified Flow, and remember, keep building smarter.